this video we are going to discuss about the Cisco SD WAN components. So in a traditional network, the management data plane and the control plane all were hosted on the single integrated router. Each router has a line card for switching and forwarding data packets. A CPU module was routing calculations, so and the command line interface for programming. So basically, if you see the traditional router, CPU is used for the calculations and the line cards are used for the data packet forwarding, and the CLI command is used to configure the device. Now, as network grows, the need for manual configuration increases. So that's definitely because as many devices you have to configure it all by manually in a traditional way, leading to complexity and potential errors. That is also true. If you do any one error, that will cause a lot of time to find out, and it will take a lot of time to fix it also, leading to complexity and potential errors. Each router must independently process routing updates. That's true. Each router has to go to the processing time. Uh, what do we say? The processing of the process, how it will be processed, the packet will be processed, and how and the when and where the packet should be forwarded. That decision should be made by the individual router itself. And process routing updates, which can be resource intensive and complex, especially in the large network. So if it is a very large network, so yes, all the devices will be using a lot of CPU. Now this setup risk under undesired outcomes due to the design flaws, because since it is a complex one and each and every device is consuming the CPU in the same way. So let's look at like an example. How I can say is that so at a branch there are not many people and you are using a integrated router. But there is another branch which is a large branch, you are using an ISR router or the ASR router. So when compared to these two, there is a lot of difference between the output of that one and the CPU and as well as the memory. So this will have an 8 GB memory, this will have a 4 GB memory, this might have only 4 cores of CPU, this might have a 8 cores of CPU. So the difference is a lot, because any branches, if you're going to keep on expanding your network, all of the routes should be implemented into the routers in order to communicate with each other. It's like a mesh topology. If it is in hub and spoke also, still you need to host that much of traffic. So the capabilities of the devices might be different on the different branches. So that's the reason there will be a CPU usage will be different on every device and every branch. So if any one of them goes overutilized, it will just reboot. And once it is rebooted, when it is rebooting means the site itself is down. So that's a very risky setup. And it is a design flaw also. Now Cisco SD-WAN address that one by distributed. Now, since you don't have management in one place, like still the device will have the management control plane at one place, but logically it will not be at one place. So what I'm saying is that there are different components. So when the device is being connected to the internet, so it will go to your what do we say ZTP server first, and it will get the vBond details, which is used to authenticate the device. So this is one of the component of SD-WAN. Once this one is authenticated, it will now forward the details to the branch saying that who is your vManage, and this is the vManage who is responsible to onboard the device. So the branch device is doing nothing. It is just going to the ZTP server first, getting the details who is the vBond. So vBond is the authentication server in the orchestration place. Okay, in the orchestration phase, vBond is the authentication server. So now the authentication will take place. Once the authentication is been successful, it will give the vManage details. Now the branch device will go to vManage and it will do the onboarding. The process will be done by the vManage. It's nothing to do with the device. So once the process of onboarding is been done, so vManage will send the all the controllers details, that is vBond details, vManage details, as well as vSmart details. So vSmart is the heart of the SD-WAN because all the policies will be implemented on this one and all the routes propagation will be done via this vSmart. So if vSmart is done, down means your SD-WAN fabric itself is down. So three components, vBond used to authenticate the devices, vManage used to onboard the devices, and vSmart which will propagate the policies and routes. So all the control plane will be done by the vSmart and all the management plane will be done by the vManage and everything, the orchestration, authentication, everything will be done by the vBond. So in this way, my device is not utilizing much of CPU. It has a minimum information where it has to go. It is just going and authenticating and doing the onboarding and grabbing, if anything, configuration file and implementing, installing that configuration file and making sure that it has all the tunnels to the controllers simply. So these are my data center or branch devices which are connecting to the vBond using the MPLS or internet or the 4G. So once they connect to the vBond, they are authenticated and they move to the vManage. They are onboarded and after that they get all the information about all the three controllers and they have a tunnel to all the three controllers. So now once the device is being connected, so it will start, SD-WAN will start getting the analytics. So it will start recording the analytics for the visibility and troubleshooting. And if you have connected to the vAnalytics, then that data will be forwarded to the Cisco cloud. So over there you can just use your AI and the machine learning to predict the or get the better solutions. So in this way, what happening is like we are not configuring anything on the device itself. It's just like an automation process which device knows what to do when it is connected to the internet. And it is grabbing the details from the management that is we manage and implementing those configuration on the device. So it is not using much of the, what do we say, CPU utilization. Now, once the device has been onboarded, now we do have the branch LAN. They are trying to communicate with the internet. And again, this decisions is now already made by the vSmart. So you push the policy saying that what you want to do, and it will vSmart will push the decision to the VH devices. So for example, now what I want to implement is that whenever they are communicating from branch 1 to branch 2, I want them to connect it via the ISP. I don't want to use the MPLS link. So I will just create a policy saying that I want to, whenever trying to communicate with branch 1 and branch 2, just to go via the internet, do not use the MPLS. So it will simply implement that policy in here. So you're pushing the policy to the vSmart. vSmart will analyze that one. And once it knows that what to do, it will push that configuration saying that you don't worry about it. Just do this thing. What vSmart is saying that, okay, whenever any of your traffic going to branch 2, don't go to the MPLS. Go via the ISP only, simply. So it's making the, what do we say, like analyzing the policy, making the decision and saying, so there is no control plane. So this is the control plane. So my device is not implementing any configuration that is been configured by the administrator on the vManage. That is the management plane. And my device is not doing any authentication because it only knows the information where to go. So from there it is grabbing the information and going to the vBond to do the authentication. So now the vBond is doing the orchestration. Okay, so this is vBond is doing the authentication and the orchestration process. We management is doing vManage is doing you the what do we say management thing, pushing and onboarding the devices and pushing the templates like configuration, and vSmart is pushing the policies and the policy decisions to the edge devices. So in this way, my device has not much to do, so I am not using the resources a lot. So CPU consumption will be less, RAM consumption will be less, SSD consumption will be very less. Okay, now let's talk about the underlay and overlay. This is now very much important. I will take an example of the branch 1, branch 2, and data center. So now when underlay means how it is connecting. For example, this is the branch 1, it is connecting to your street bit, and from the street bit it is connecting to some other place, and from some other place it is connecting to the uh, point of interconnection, and from there it might be connecting to your some of the organization. So I'm in Australia, so I will be talking about the NBN. So how the NBN is connected over here, the cabling is that from the branch device is connected to the local street, then it will connect it to the some other local street pits. So it will go through the different pits, and finally it will reach to a point of interconnect that is like an bulk of services coming and connecting at one place. Okay, so from there it will be connected to the data centers. And this in this data center, the ISPs will have some what do we say pools, and within that pools, if customer wants to connect to so and so ISP, NBN is the company which is going to configure that service in such a way that it will just connect directly to that ISP. So we will say that it is ISP1. So my branch is 1 is connected to ISP1, so it will allocate that a pool. So we will say that is pool 1, that is P1. So now your branch device will be mapped in such a way that will be ISP1 and your branch 1 will be in the same pool. Same thing, branch 2 will also be connected to the street pit, then again to the point, then again to the data center over here. And this one is connected to the ISP2. Alright. Again, the data center is also connected to the street pit, then to the point, then to the data center, and this is connected to the ISP1 again, same provider, P1, and here P2. Now, since these two branches are lying on the same service provider, it will be easy for the service provider to have a to make your path in such a way that communication will be very easy. So your service provider will be responsible. It will assign you a public IP if you like. If you don't want a public IP, we will then have to go via the MPLS. So we'll go by the public IP. That means any devices can come on the internet that is visible on the internet. We don't have to worry about the ISP1 and ISP2. Simply is that. So I do have a public IP PUB1, here PUB3, and here PUB2. So I have a public IP address associated to the individual branches and the data center. So this is my underlay because this is how things are connected. All right, so this is how things are connected. Once things are connected, now the overlay. So how the overlay will be that this is my branch 1, this is my branch 2, and this is my data center. So once I have connectivity, so they are now connected with each other. How they are connected? This is how they are connected in the underlay. But with the overlay, once they are connected, they are able to reach the branch device. With what it will do, it will create a tunnel, and it will also create a tunnel to here. Similarly, branch DC will also create a tunnel. So now they both will have one tunnel only. Okay. The DC will also have a tunnel with the branch too. Now, logically speaking, branch 1 is directly connected to data center. Branch 1 is directly connected to branch 2. So this is how my diagram is now logically. Similarly, data center is connected to branch 1 directly and branch 2 because there is a tunnel directly connected to each other. So logical diagram will be this is how it will be. But underlay, it is connected via the different point of contacts. So NBN is the company in Australia which will be responsible for giving the connectivity between your ISP provider and your branch or your office premises. So these people are responsible to connect in such a way that you have a layer 2 connectivity. Simple. So they have a very complex configuration. Again, that's a different story. We don't worry about it. But just to give an idea how things are connected. And finally, you have your branch connected to your ISP via the layer 2. And after that, it is ISP is going to configure your circuit, your service on this particular premises. And after that, you are able to communicate with the internet. But that is the underlay. But overlay, logically speaking, it creates a tunnel, the SD WAN. So that means you're directly connected. You don't see these many things going on. And if there is a LAN over here, which is trying to communicate with the servers and applications at the data center, so whenever you do the trace route, what happens is like first hop will be the internal interface of the branch 1 and second hop will be the internal interface of the data center 2. Simply, there is no hop. It will not show you any hop of the ISP because if you don't have these tunnels, what happens is like, so let's understand this is your applications over here and this is your LAN over here. So when I do the trace route on the overlay, it has only two hops. One is going to your local interface and another going to the local interface of the data center. But if I don't have that tunnel, if there is no tunnel, then traffic is like first hop will be your internal interface, second hop will be your external interface, that is your egress, and after that it will be your ISP, then again your ISP core. So there will be different devices through which it will going, and finally it is reaching to your DC ingress, that is external interface, then going to the internal, then going to the application. So these are the multiple hops you are able to see when there is no tunnel connectivity, no overlay. But when you have an overlay, you just have two hops. So like 10 or 15 hops and two hops. That is the difference. So irrespective of how your service is connected underlay, the main thing is that how things are connected overlay, how you want to connect your branches and devices overlay, that will make a lot of impact on your services. So I hope you understand the underlay and the overlay. We already discussed about the management plane, orchestration plane, control plane, and the data plane, which already resides on the different services. Like control plane, management plane will have with the me manage and the vBond. Control plane is all has with the vSmart, and the data plane also will have with the vSmart and the branch devices, because vSmart has the policies, and according to that policies it will send the decision to the branch and branch will implement those, forward that data. So branch devices will forward the data, not the vSmart. Control will come, vSmart will come under the control, vManage and vBond comes under the management and orchestration plane, because authentication will be done by the vBond, onboarding will be done by the vManage. So orchestration and management is like we are accessing the dashboard of the vManage and we are actually configuring the devices remotely using a dashboard or web interface. Now, SD-WAN deployment types, again, you can have multiple controller deployments. So usually in a lab, I will go with the one vManage and one vSmart and one vBond. You can have multiple vSmarts. and you can also have multiple vManage. Now with the vManage, there is a condition. If you want to have more than one means, then you need to configure three of them. You cannot configure two of them. But with the vSmart, you can configure one, two, three, how many you like. Now with the vBond, it's a little bit tricky. You can configure as many vBonds you like, but in a device, you can configure only one vBond. So this vBond, you cannot have the IP address now because you need to have the FQDN because you do have multiple vBonds. And you need to have some kind of mechanism to do the load sharing. So whenever this FQDN is being hit by the device, there should be a device which should be capable of doing a load sharing, sending the traffic to the respective vBonds according to the traffic load. So this is the only tricky part. And apart from this, you don't have much tricky part with the vSmart and the vManage. Okay, that's the multi-controller deployments. You have to be careful with that one. On premises, usually we have only one vManage, vSmart, and the vBeyond, which will be a virtual device mostly. Maximum, it will be a virtual device that will be hosted by the own organization and controlled by the own organization. Cloud, if you like, you can deploy the same vManage, vSmart in the Cisco Cloud. So Cisco Cloud or maybe a Google or maybe an Azure, the cloud provider will be responsible to implement, deploy your vManage, your vSmart, and the vBond. You just have to select the templates, and the provider will be responsible to deploy those services for you and give you the access for that one. So you do have a different option to go with, and accordingly, according to your organization, if it is a large, small, or medium, according to that size, you can make a decision for that one. So I hope this was informative for you, and thank you.